Let's take a look at another situation here where I'm actually dealing with some quadratics. See, this is a repeated quadratic term. I have the same quadratic that's repeated because of the exponent. So the way I'm going to write this is I'm going to say that 2x squared plus x plus 8 over x squared plus 4 squared equals, now I'm going to use a, b's, and c's just because I want to. I'm going to have ax plus b, see this is a quadratic, so I have this linear term here, over x squared plus 4 plus cx plus d over x squared plus 4 squared. So now if I multiply through by x squared plus 4 squared, I'll clear all the fractions, and then what I end up with is 2x squared plus x plus 8 is equal to ax plus b times, I'm going to have one of these x squared plus 4's left over, x squared plus 4 plus cx plus d, because the denominator cleared here. Well, I'm going to distribute, and I see I'm going to have 2x squared plus x plus 8 equals, let's see, I have ax cubed plus 4ax plus bx squared plus 4b plus cx plus d. So now what I'm going to do is I'm going to combine like terms. So I have 2x squared plus x plus 8, left-hand side hasn't changed, equals, this is the only cubit, so I have ax cubed plus, what do I have for quadratics? This one term right here, b, so bx squared plus, I have 4ax and cx, so that means I have 4a plus c times x. I combine my linear terms, plus my constant terms will be 4b plus d. Now I need to solve for a, b, c, and d. It sounds like it's going to be a mess, but it's really not. What I'm going to use is a technique that referred to as simply equate coefficients. Remember, the left-hand side has to equal the right-hand side. So the left-hand side doesn't have a third-degree term in it, does it? That means that a must be equal to 0. Well, if a equals 0, this just got simpler. So we took care of the third-degree term. How about the second degree? Oh, it's 2x squared. So 2x squared has to equal bx squared. That means that b must be equal to 2. Well, now I have this taken care of and this taken care of. Whoops, not that. Sorry. I have b taken care of. Missed. Okay, the linear term. I know that a is 0. So if a is 0, this is really simply c times x. The linear term is 1, so c must be equal to 1. So now I've got that taken care of and that taken care of. All that's left is, well, I know what b is. b is 2. This last piece says 4 times 2 plus d must be equal to, well, the constant term is 8. Well, that can only happen if d equals 0. So now I have all of those constants. So now I can go ahead and work out the integral. The integral is going to be, see, a is 0, so this piece goes away. b is 2. 2 over x squared plus 4 plus, see, c is 1, so I'll have x plus d, but d is 0, so it's just x over x squared plus 4 quantity squared dx. See, that now will be easy to integrate. So I'm going to switch pages and have a little more room to write here. See, I've got the integral of 2 over x squared plus 4. I'm just rewriting it so I can see it fresher on this page. X squared plus 4, this was squared dx. Okay. This is pretty simple. This is simply going to be 2 times, this right there's a 2. If I pull the 2 out, it's 1 over x squared plus 4. That's x squared plus 2 squared. That is going to be arctan of x over 2, like that, all over 2. That's just first component. So these 2's will end up canceling. The second component is really not complicated, because if I let u equal x squared plus 4, then du equals 2x dx. That means that du over 2 equals x dx, which is exactly what I need. So I can take this as 1/2 times the integral of u to the negative 2 du, which is going to be 1/2 u to the negative 1 over negative 1, which obviously I would write as a negative 1 over, say, 2u. But what did we say u was? U was this. So this is a negative 1 over 2 times x squared plus 4. Now, I guess we could multiply this 2 through here. Whatever, it doesn't really matter. So this is one of the parts, and this is another part. So my original problem was the integral of 2x squared plus x plus 8 over x squared plus 4 quantity squared dx, and that is equal to arctan of x over 2 minus 1 over 2 times x squared plus 4. Like I said, if you want to distribute that 2, knock yourself out, plus c.